This is the Math 2 Unit 8 circle review. We start with our diagram here of just identifying parts. So the center of the circle is a point, that is point P. The radius, we could say a few of them. We could go PN, PM, or PL. Any of those would be radii. The diameter, though, has to be NL. That's a segment. For a chord, we could say KL and ML are both chords. They start on the circle and end on the circle. Technically, NL would also be a chord, but that's really better just to call it a diameter, like we did here. The secant is a line that hits the circle at 2 points, goes inside the circle, but extends beyond it. So JL would be our secant. The tangent would be one that hits the circle at 1 point, and it's perpendicular to the radius, so we're going to call that JN. For a central angle, we got a few options. That's just an angle that's based in the center, so we could go here or here. So let's go angle NPM. You know, a central angle is a central angle if the vertex is the center of the circle, which we said was point P. The inscribed angle is going to be an angle with the vertex on the circle that hits an arc. So M doesn't quite work because this doesn't extend over. So L does extend out. So KLN would be our inscribed angle. Minor arc is an arc that's less than half the circle. So we'll say NM is a minor arc. Remember the little arc above it. ML would also work, NK or KL. A major arc needs to be more than half the circle, and that's going to be 3 points. So I could go KML. So follow the path, KML, put a little arc above it. Semicircle is 3 points, so let's go NKL. For the second one, we have central angle. So what I like to do here is first go in and find all the values first, and then it allows me to then find the parts that I need. So I have 79 and 53, and that's part of the 180 that's on the top here. So let's go 180 minus 79 and 53 leaves me 48 here. I have a right angle, which is part of the 53. 90 minus 53 gives me 37. And that's 180 on the bottom, so 180 minus 37 gives me 143. So now that I have all these parts, I can go in and find the arcs. So CD is 37 degrees. AB is 48 degrees. ED is 143. EB is going to be 79 and 48. Add those together, I get 127. BDE starts at B, goes through D, ends at E. So it's 53, 37, and 143. So that's 233 degrees. DEC starts at D, goes through E, ends at C. So I could add up all of these parts, or it's really everything but the 37. So instead, let's do 360 minus 37, which gives me 323 degrees. For our next one, I'm going to use central angles again to solve. If I look what I have here, so I got 45, I got 28. These are on the kind of this split bottom half of the circle. I could also split it this way and see the 45 and the 6x plus 33 is 180. So I'm going to go with that one. So let's do 45 plus 6x plus 33 equals 180. So that becomes 6x plus 78 equals 180. I'm going to subtract 78 from 180, and that gives me 6x equals 102. 102 divided by 6 is 17. For number 4, we can look at it, and I have vertical angles here, which means the arcs are congruent. So 13x plus 3 equals 15x minus 7. If I subtract 13x from both sides, we get 3 equals 2x minus 7. We add over the 7, we get 2x equals 10, and x equals 5. So now they want to find EF, though. I can find one of these arcs, and then it's the supplement, it's 180 degrees, combined for this arc. Let's go with this one. So we're going to do 13 times 5 plus 3. 13 times 5 is 65, plus 3 is 68. So now we're going to go 180 minus 68 to get 112 for our arc. So the measure of arc EF is 112. For our next one, we need to find our chords and arcs. So I have that AD is 12, CB is 10. I need to find AB, a little X there. This actually becomes a right triangle. So we got X, I got 12, and not 10 here, but 5. So this is a Pythagorean triple, or Pythagorean theorem problem with a right triangle. So we're going to go x squared equals 5 squared plus 12 squared. X squared equals 25 plus 144, which gives me x squared equals 169. So x is 13. For our next one, we have GP and PH are the same, so they're equidistant. GA is 17 and ED is 37. Oh, let's also get the fact that AB is 87. So let's first do the segments. So I got AG is 17. So I got 17, 17, 17, and all of those. So that might help me. For DB, it's the two 17s together. It's 34. For EG, it's 17. And now we can look at arcs. Well, I know that these two arcs are the same right here. So let's pull our congruence there. I know those match. I got to find what those need to be. So let's take 360 minus 37 and 87, and that leaves 236 total for those two. Now let's divide them by 2, and they're both 118. I can go a step further because these are then bisected, and they're both 59 degrees. So now we go back and let's see what they're looking for. So DB is that arc, 118. FA is 59. And DC is 59 as well. Inscribed angles are next. So for inscribed angles, for ML, this arc, we're going to double its inscribed angles, which is 118. For JLK, so the angle opens to this arc, so we take half of 134, which is 67. JLM is this angle. So for this, I want to know the arc over here, but I have a diameter, so let's take 118 from 180, and that gives me 62. So if that's 62, and I take half of that arc, it gives me 31 degrees for that angle. And then last, they want the measure of MJ, which we actually already found, and that was 62 degrees. For number 8, this is just a basic inscribed angle problem. You're not going to set them equal. You're going to either take half of 94 equals 9x minus 25, or you double 9x minus 25 and set it equal to 94. Mathematically, this is the same thing. So instead of dividing by 2 at one side, I'm doubling the other side. You just need to make sure you're following that rule correctly. So let's go 18x minus 50 equals 94, and 18x equals 144. So now 144 divided by 18 gives me 8 for x. And number 9, BCD, oh, it's an angle, not the arc, is 7x plus 10. Arc BAD is 19x minus 50. So the same thing as before. We want to find that arc. So I'm going to go 2 times 7x plus 10 is equal to 19x minus 50. I'm not going to take half of this because I don't want to take half of 19. I'd rather double something. So we got 14x plus 20 equals 19x minus 50. We subtract over the 14x, we get 5x. We're going to add the 50 over, we get 70. Now 70 equals 5x, gives us that x equals 14, but we have to substitute back in. So the measure of BAD, the arc, is 19 times 14 minus 50. 19 times 14 gives us 266, and gives us an answer of 216 for measure of arc BAD. For number 10, we have angle K is 8x minus 19. Angle M is 5x plus 43. We have to find angle M. In this case, we know that these two angles are supplementary because it's a quadrilateral inscribed within the circle. And that works because if I doubled this angle, it would be this arc. And if I doubled this angle, it would be this arc, which then they would then have to add to 360 because they make a full circle. So because we take half, the 360 becomes 180. It's just a little shortcut that we have to solve whenever it's inscribed. So let's set it up here. I got 13x plus 24 equals 180 after I combine like terms. I'm going to do 13x equals, let's do 180 minus 24, gives me 156. 156 divided by 13 is 12. Now we need to find the measure of angle M, which is 5 times 12 plus 43. That's 60 plus 43, or 103 degrees. For our next one, we have our tangents, and I'm going to move this radius over, make this 8. So we then have 19, and it's just using that to form the right triangle. Sometimes they split up that hypotenuse. So 19 squared is equal to 8 squared plus x squared. 19 squared is 361 equals 64 plus x squared. If I do 361 minus 64, it gives me 297 equals x squared. Now that's going to be the square root of 297, which 297 we can simplify. 297 is going to be, let's go 297 divided by 9. I know 9 is a perfect square. So it's 9 times 33. So that's going to become 3 root 33 because the square root of 9 is 3, comes out. So we have that, or if they want it as a decimal, you could do the square root of 297, which is about 17.2, and it just depends on the type of question that it's asking. For the next one, I have 3 here as the radius. I'm going to put the other 3 here and make the diameter 6. So we got x, 3.2, and 6. X squared equals 3.2 squared plus 6 squared. 3.2 squared is 10.24 plus 36, or 46.24, equals x squared. Since it's already a decimal, I'm just going to take the square root of that, and that comes out to be a 6.8. Now on the next one, 13, common tangents are congruent. So 4x plus 23 equals 10x minus 19. If I subtract the 4x to both sides, I get 6x. If I add the 19 over, I get 42. So 6x equals 42. It gives me x is 7. Now they want EF, which we know is 10x minus 19. So that's 10 times 7 minus 19. 70 minus 19 gives us 51 for the length of EF. For number 14, we're going to have to use that common tangents idea to help us out. So what's the perimeter? Well, I know that these are common tangents, so this is also 5.9, as well as this 12.2, 12.2 puts us there. So now we could combine those. 5.9 and 12.2 gives me 18.1 there. But I still need this side. Well, I know 27.1 is the whole thing. or 27.4. So let's do 27.4 minus 5.9. That gives me 21.5. Now, that's also the same as this side, because they're common tangents, which becomes 33.7. So my sides are 27.4, 18.1, and 33.7. So now when I combine them, it's going to give me my perimeter, which is 79.2. For number 15, we're looking for our tangents and secants intersecting. So let's start with this arc here. We have 98 degrees. This works just like an inscribed angle. So this angle is going to be half the arc, which makes it 49 degrees. What we could then do is notice that these are supplementary. So we could do 180 minus 49, which gives us 131 degrees. And that, again, acts like an inscribed, so it could double and be 262 degrees here, which, if you notice, 98 and 262 come out to be 360. So we can use this relationship of 360 as the total of the arcs, or if you took half of them, the total of the angles is 180. Now let's look what we're looking for. QST is the angle, so that's 131 degrees. QS is the arc, that's 49 degrees, which is actually what they gave us. QUT, which is the arc, is going to be 262 degrees. For the next one, we have MOP is 11x minus 38. LMP is 3x plus 41. We need to find NMP, which is the angle here. So we're going to use these two to allow us to solve. So I'm going to double the 3x plus 41. Set that equal to 11x minus 38. So we have 6x plus 82 equals 11x minus 38. Subtract the 6x over, I get 5x. I'm going to add 38 to 82. And I get 120 equals 5x, which gives me that x is 24. Now, since I'm looking for this angle, I want to know this angle. So let's go 3 times 24 plus 41 gives me 113. So the angle NMP is going to be 180 minus 113, which is 67 degrees. For our next one, we have tangents to the circle. So if we have tangents, we know they are perpendicular, and we need to find the measure of angle E. What this becomes is a quadrilateral, and in a quadrilateral, we know the angles add up to 360 degrees. So the measure of angle E plus 90 plus 150 plus 90 is equal to 360. These together, we get 90 plus 90 is 180, plus 150 gives us 330. I'm now going to subtract 330 from both sides, so the measure of angle E is 30 degrees, which is A. For number 18, we have a tangent, so again, right triangle. This becomes a Pythagorean theorem problem, because we have 25 here. So 25 squared equals 7 squared plus x squared. That's 625 equals 49 plus x squared, or x squared equals 576. When you take the square root of 576, you get an answer of 24. For number 19, we need arc BCD, which is all of this. Well, I know part of it's 144. I need to find the other portion. But since this is half the circle, we're going to do 180 minus 34 to get 146. So 144 and 146 gives us 290 for the arc. For number 20, we need to find LN, which is the arc out here. What we first notice is these two chords are congruent, so that makes these two arcs congruent. Now that's not common notation to mark them congruent, but I'm just going to use this to help me out. This is also an inscribed angle. So let's double 28. 28 times 2 and we get 56. So if we called these both x and we had to solve for it, we would say 360 equals 56 plus x, or 360 equals 56 plus 2x. That becomes 304 equals 2x, and x is 152, which is answer C. For number 21, we have to use the fact that we have opposite angles are supplementary in an inscribed quadrilateral. So we'll say 2x plus 4x equals 180, which is 6x equals 180, so x is 30. For number 22, I'm going to draw x right here. It's a radius. So then I got 8, 15, and x. So x squared equals 8 squared plus 15 squared. X squared equals 64 plus 225, or x squared equals 289. The square root of 289 comes out to be 17, which is an answer D. For number 23, we have the measure of angle PLM is 42. We need to find MNL, which is the angle right here. Well, let's work through this. First of all, I know this is an isosceles triangle because these are both radii, so that's 42. I can then find the third angle into this triangle, so 42 and 42 is 84. Subtracted from 180 gives me 96. This helps me a lot because this is a central angle, so this is also 96 degrees. Then n is the inscribed angle to 96, so I'm going to do 96 divided by 2 and get 48 degrees for my answer. For number 24, we have TWY is 74, we need WPT, which is the arc. Two ways we could get to it. Let's go one way. We could double 74, and that gives me 148. This is the arc here. I'm going to do 360 minus 148, and I get 212, which is my answer. The other option is to do 74, subtract that from 180, which gives me 106, which is the angle here, which I could then double, and it also gives me 212. So either method would work. For number 25, we need the measure of angle PAM. Well, this one's actually a special case, because if I notice this angle here, it opens to the arc that's half the circle. And since I know that's 180 degrees, that makes this angle 90 degrees. Another way we could get to that is I could take half of 156, which is 78. I could do 180 minus 156, which would give me 24. And then take half of that to get 12, and then between the 12 and the 78, that makes my third angle 90. So just another option to get there if you didn't see the rule. For number 26, we have AGH, which is the angle here. This one, we can be a little deceiving how to work through, but what actually helps us a lot here is this 52 is an inscribed angle. That makes this arc 104. Now, G is also an inscribed angle to the same arc, so that would also be 52. Because inscribed angles that go to the same arc are congruent, they're both 52 degrees. For number 27, I have tangents. So I'm going to draw in my tangents here, put the right angles in. I need arc BDA. So let's first find, so let's call that X. Let's find Y. So this is similar to an earlier problem where we know that 43 plus 90 plus 90 plus Y equals 360. So let's do 90 and 90 is 180. 180 plus 43 is 223. If I subtract that, I get 137. Now, I know this is not X, but that 137 is also the central angle to right here because it matches to the arc. So now I could go 360 equals Y plus 137, by subtracting it over, not y, we're going to go x. So by subtracting it over, 360 minus 137, I get 223 as my answer for the arc. So it takes a couple of steps, but it's still using the rules that we have. Okay, last page here. We have that TR is 110. We need to find TS. Well, since I have congruent arcs, 110 also is going to go here. So I could say the measure of TS plus 110 plus 110 equals 360, or the measure of TS plus 220 equals 360. The measure of arc TS is therefore 140 degrees. For number 29, we know that GMJ, all of that is 220. This is actually bisected, so we each have 110 and 110, but also because KM is a diameter, we get 70 here and 70 here. So by filling these in, it actually helps us. GK is this arc, which is 70 degrees. JM is this arc, which is 110 degrees. Your last part there is all of the rules we have. I would make sure you can identify them and understand the rules between them, especially between central and inscribed, and be able to solve the problems that you have.